Alright guys, I'm back with another old school episode. So remember 2013? Yep. Well, I'm back with another episode. I would program this one from scratch, but it needed a lot of debugging and trying and testing, and it would have been really hard to follow. So, instead of programming, sit back and relax. Eat your popcorn and just watch as I explain and show you this new app, this new program I called CIR, for short for circle. Okay, because all it really does is draw a circle, but it's to help you draw circles so that you can use them in Minecraft. So, and it's not very sophisticated, but it does give you the option to sort of add or subtract to the thickness of the circle, because I know that kind of makes it tricky. You don't really know all the time which, if you want to make just a solid circle, but you don't want to use more blocks than you need to. This lets you sort of adjust the thickness on the fly to sort of reduce or add, so that maybe you have a gap and you want to fill it in, but maybe there's another part of the circle which there's like 2 blocks where you only need 1, and you want to see which one is more necessary. So anyway, let me show you how the program runs first, and then we'll sort of dissect it a little bit. So let's go ahead and just pick a radius of 8. Okay. So here we go. Now this is the edge of the circle. So if I press left, it's going to reload, but it's going to shift over everything to the right a little bit. So we can also move up. So I'm going to move up. And there we go. We're seeing a little bit more of the circle. And there we go. That's axis. I decided to show the axis because it was hard to tell where the center of the circle was, and I knew that if you did really big circles, it would get really frustrating. But now you can sort of see, like, okay, if I'm going to build a circle in Minecraft, see, you don't really need this corner though. So I added 2 more buttons to sort of decide more, I guess, the thickness of the circle. So I'm going to go ahead and reduce that a little bit. It might get rid of the block, it might not. Oh, it did get rid of the block. So now you can see there's still no gaps. So now that we actually have a pretty good circle here. But I can also increase the thickness. So I'm going to hit that, and we're going to see that corner come back, but I'm going to increase it more. So now we're going to see potentially more corners coming. And more corners. So here we go. We're increasing the thickness little by little. And you'll see, so depending on how thick you want it to be, you can go ahead and do that. And notice in the upper left corner, there's a little minus sign when I'm running. So let's go ahead and run it again, but with just 5. Okay. Notice we got just a little circle here, and it pretty much draws it pretty good. I mean, the decision factor that we start off with is an error of 0.5. So if whatever the circle radius lands on, if that's within 0.5 units from whatever block we're talking about, or whatever, unit square we're talking about, then it fills it in. Otherwise it doesn't. But that's not really, I don't think that necessarily works perfectly. So, because I don't have a fill algorithm to check whether we have gaps and things like that, I just I leave that up to the user to kind of add or subtract thickness as needed. So here we added some thickness, we have some corners. So this is a program that you can use. It's intended for me to sort of, if I'm playing Minecraft and I want to make a giant, let's say circular floating island in the sky, which I love doing that in Minecraft. I love making big circles, big UFOs, and things like that. This is just another way to do that. Now, I didn't make it so that you have separate floors, but if you wanted to, you can make different size circles and sort of use a cross-section circle to say, how you want that to go. Like maybe at the bottom you want it 5, and you want it. But there are more ways there are more algorithms, which you'd want to use a filling algorithm to do this, I think. If you really wanted to do a good, like a big oval kind of toward, like three-dimensional ellipsoid, kind of like a sphere, but think more like it could be an oval, it could be like a shape of an egg a little bit, or it could be like just a big ellipse, but in 3 dimensions. You'd want to use, you know, plots or one of those websites to help you do that. Maybe you do something in JavaScript. But as far as just drawing circles, I think a calculator app might be pretty practical for helping do that. So I'm going to show you guys the code, and I'm going to explain every little bit of code here, because I didn't show you coding it for this episode. And usually when I do a calculator programming video, I code the entire thing and show you all my mistakes and everything I was doing wrong. So one of my mistakes was I was actually multiplying r by square root of 2. And you might be thinking, what does square root of 2 have to do with anything? Well, if you think about a triangle, a right triangle, okay? The long side of a right triangle, okay? If your triangle is an isosceles, if the height of the triangle equals the width of the triangle, then that means the hypotenuse is going to be square root of 2. Okay, so if you're trying to start with a circle and you want to zoom in on part of the circle that's interesting, you might want to zoom in on the curve. But if you zoom in on the curve, where does the circle end up? How far away is it? Well, it's not halfway to the radius. It's about 0.7 something. Okay, it's about square root of 2. I'm sorry, 1 divided by square root of 2 distance away, if you're talking about the radius. If you're talking about the diameter, I'm not sure. But yeah, it's about 1 over the square root of 2 distance in the x direction, and then that same distance in the y direction. So then I subtract 4, which is half the screen's height, and I subtract 8, which is half the screen's width, so it centers it on the screen. So S and T represent sort of our window, like center, I guess, or our window coordinates. Not the center, but the corner. So E represents our error, so that's how thick the circle is going to be. And then R represents the radius of the circle. So if we want a circle that's 10 from the center, or a circle that sticks out just 5 blocks from the center, you don't know. So I'm going to erase this because I don't need it. That's just some debugging. And then we have an infinite loop here. Okay, so we clear the screen each time. And then what I did was I only loop through the blocks in the screen, because otherwise it's really slow. So I only loop through blocks that can appear on the screen. Then I calculate the coordinates based on where the screen is, which is S and T. I calculate the coordinates of each pixel, of each character, so that I can check whether it's part of the circle or not. Okay. So if x is 0 or y is 0, that's going to be one of the axes. So that's when I print out the asterisk. Okay. And then to see if it's part of the circle or not, I check this. So I take the square root of x squared plus y squared and see how that compares to r. Now I tried comparing x squared plus y squared to r squared, and that ended up being a problem, because no matter what I did with E, whether I squared it or not, the smaller circles were a lot thicker than the bigger circles. So I had to take the square root of these. That way the error is going to sort of work the same way on bigger circles and smaller circles. So this just checks to see how far away is my pixel from the center. And if it's within a certain range, if it's within E, then it's considered a pixel that's part of the circle. Okay. So if it is, then of course we print out an O at at the coordinates that we're going through. And O and N, remember we calculated O and N. Those are just the screen coordinates. So an O and N, that's why we're printing an O there. Okay, so that's inside our loop. But then when that all finishes drawing, we just output a minus sign at the top left to show that we're done. Okay, because otherwise it's kind of hard to track you don't know whether it's done processing or not. So I just kind of put a minus sign at the top left corner of the screen. Then I check to see if we're going to press anything. So if we press something, for example, if we press 24, that means we pressed up. So S minus 1 stores up. So that means we're moving our screen window upwards, basically. Okay, so the coordinates of our screen basically goes up a little bit. Okay, and then of course, if we move right, or if we move, oh, this isn't up, this is left, sorry, I lied. This is left, this is right, this is up, and this is down. 34, we add 1 T. And then we have 2 more buttons we press. So this is the second button, the second key, which is the blue key. And this is the alpha key, which is the green key. And I sort of multiply or divide by 1.1. So I don't multiply this one by 0.9 because I want to be able to reverse what I already have done with E. Basically, it increases the error a little bit here, and here it just decreases it a little bit. And I increase or decrease it basically just by 10%. So, or I increase it by 10% and then I decrease it by whatever the inverse of that is. So that might be like I don't know, 0.9 something, a little more than 90%, I guess. And that's how you get it. Actually, what is that? 1 divided by 1.1. Yeah, so just a little more than 90%. That way when you increase it again, it reverses it. So it's a very simple program, but it's a program that is useful. So if you want to play Minecraft, there you go. You can have a little calculator program that helps you draw circles. So let's say you're playing Minecraft and you want a circle that's about 12 blocks long. Okay, so then the radius of that would be half of that, which is 6. So you'd go ahead and enter 6 for the radius, and then there you go, you have a circle that has a 6 radius. And then you can move up a little bit so you can see both axes. Okay, and now let's say you want to start building that circle, but you don't like the walls to be that thick. So you can hit alpha, makes it a little bit thinner, still a little too thick. Let's hit alpha again. Still didn't get rid of those corners. There we go. Okay, so I guess it's basically gonna look like that if you don't want those corners there. Okay, and then there's your circle. That's how you build a little. Doesn't look too much like a circle. It looks more like an octagon with this small one. But if we do a bigger one, it's going to look more like a circle. So if I do like 55, boy, look at that. Look at that. So I'm move up. This is going to be a big circle. Right, but at least I made it so that you could find the center, or find. I guess I could make it so that instead of starting in the corner, so anyone who's actually going to use this for Minecraft, let me go ahead and give you an easier option here. So instead of doing this, where you do the root 2 for both of them. What I could do is what you could do is you could just set 0. So So instead of r divided by square root of 2, you could just set one of these to r and one of these to 0. And we'll just see how that works. So let's try 55. There we go. Okay, so now basically it's a really big circle, but you start at the bottom of the circle. So now if I press right, okay, I can see more blocks. Okay. Does that seem good? So, and then another thing I can do is, if that's also a little slow, here's one other thing I can change. So another thing we can change for actually using this for Minecraft is, instead of just adding 1 to these, I'm going to add 8 to the 24 and 26 ones. And then for the 25 and 34 ones, I'm going to add and subtract 4. So that's half the screen. So now if I do a circle of size 55 and draw it, and I say, okay, I want to move to the right some. If I press right, I move to the right a lot, and I move up. I moved up a lot. So, and we could also add more vertical and horizontal lines if you really wanted to. You could add vertical and horizontal lines for showing you sort of where you are, or you could print out the coordinates of what window you're looking at, and things like that. You could also, instead of putting O's here, you could probably put like a digit of the X coordinate or something like that. There's a lot of little tricks you could do with the code to help you find out where you are. Let me know what you guys think. I think there still needs to be some editing to the code to make it more useful for large circles in Minecraft. But it is something that we can use so far. So far it looks like it sort of does work. So this has been Calculator Programming with Tim. I hope you guys enjoyed this episode, and I'll see you again next time.